In this video, we're finding volumes of solids with known cross-sections, and this time the cross-sections are semicircles. Well, remember, with this sort of a problem, and we call this a Plato problem, we are always integrating the area function of the known cross-section dx. Well, formula for the area of a semicircle. Well, semicircle is half a circle, so that would be half pi r squared. Well, now let's think about what r is. If I have a cross-section, which are semicircles, and there's my semicircle, notice that the cross-section between the top of the bottom function, that's actually the diameter, and if you look at a semicircle, it actually looks like a big D to remind you that that's the diameter. So if diameter is our top function minus our bottom function, then the radius is half of the top function minus the bottom function. And remember, we don't want radius really, we want radius squared, so we're actually going to have to square half top minus bottom in order to get radius squared. So let's go ahead and start this problem. Now I don't much care for the half pi, so I'm going to go ahead and bring that out front. So I've got a half pi integral. They were nice enough to give us the bounds, 0 to 1/2. Now I need r squared. Well, so that's going to be 1/2 of my top minus my bottom function. I'm going to have to square that dx. My top function from the x-axis is clearly g of x, so I have g of x minus f of x quantity squared. Now, I suppose I could clear that up a little bit if I were to distribute my square. If I square the 1/2, I would get a 1/4, and I could bump that out in front if I want. If I do, then I would get volume is pi eighths out in front. Then I could just leave my g of x minus my f of x squared dx on the inside from 0 to 1/2. So I've got an option there if I want to pull that 1/4 out in front, which would be easier if this is a by hand problem. If it's a calculator problem, then we wouldn't much care. So again, with a semicircle, we have to be really careful. The top minus bottom is the diameter, not the radius.